Welcome to qnawire.
Hi, so over here we're asked some questions regarding a reaction of combustion of C3H8. So the first step is going to be to balance the corresponding reaction to produce CO2 plus water. The first thing that we're going to do is to balance the number of carbon atoms that we're going to get. In this case, we have 3 carbon atoms on the left-hand side, so we need to multiply this factor by 3. Now, let's balance the hydrogen atoms. We are going to have 8 on the left-hand side, so we need a factor of 4 over here. And finally, balance the oxygens. We are going to have on the right-hand side, we're going to have a total of 3 times 2, 6, plus 4, 10 oxygen atoms. So we're going to have a factor of 5 in order to balance properly this reaction. So now that we have the balanced equation, we can proceed with our questions. So the first one is going to be, if 520 grams of CO2 was made during the balanced chemical reaction, how many moles of C3H8 would be needed to carry out the reaction? So if we start with 520 grams of CO2, we know that CO2 is going to have a molecular weight of 44 grams per mole. Let's set it over here, 44 grams per mole. And additionally to that, we know that 3 mole of CO2 comes from 1 mole of C3H8 from this hydrocarbon. So the result would be equal to 3.94 mole, rounding up our answer to 3 significant digits. Now, if the same quantity of CO2 was made during the balanced chemical reaction, how many grams of oxygen would be needed to carry out the reaction? So the procedure is going to be exactly the same. We're going to start with the grams of CO2 that we have. We're going to employ the conversion factor to turn grams of CO2 into moles of CO2. And now let's use the stoichiometric relationship that we have over here. We know that 3 mole of CO2 come from 5 mole of oxygen. So 3 mole of CO2 are going to come from 5 mole of O2. And finally, the molecular weight for oxygen in order to transform moles to grams is going to be equal to 32 grams per mole. So 32 grams of O2 are going to be equivalent to 1 mole of O2. Doing these operations, as you can see, the units are going to cancel out, and we're going to end up with grams of oxygen. So the result that we're going to get is going to be equal to 630.3 grams of O2. And finally, the same procedure, how many molecules of C3H8 would be needed to carry out the reaction? So we have actually already calculated the amount of mole that we require. So the number of molecules would be equal to the amount of mole of C3H8 multiplied by Avogadro's number. So this is going to be equal to the value that we got, 3.94 mole, times 6.022 times 10 to the 23 molecules per mole. So the result would be 2.372668 times 10 to the 24 molecules. Rounding up to 3 significant digits, this is approximately 2.37 times 10 to the 24 molecules. And with that, it would be all. Thank you very much, and have a good one.